Hello my dear students, welcome back to my class in the series of learning data structures through C. In the previous video, we discussed about stack. We understood about what is stack and the values of top pointer and some basic fundamentals of stack. Well, in today's video, we will see the memory representation of stack. And we will also understand the two methods of representing the stack in the memory, that is using arrays and linked list in detail. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end and do not skip the video. And if you please like the video, click on the like button and share the video to all your friends. Memory representation of stack. That is how we can represent the stack inside the computer's memory. So the representation of stack in the memory can be done in two ways. So there are two ways to represent the stack inside the computer's memory. One is the static representation. Static means fixed. Static representation using arrays. So we can do the static representation using arrays. The other one is dynamic, which is not fixed. Dynamic representation using linked list. So let us understand these two methods in detail now. So here we go with the first method, that is the static representation using arrays. The name itself tells you static. Static means fixed. And array, of course, we all know it is the linear data structure and the elements are in fixed size. So if I just say I can store maximum 10 elements, it is maximum 10 elements I can store, not more than that. I can store less than that but not more than that. So when I say I use the array data structure to implement the stack, so I can implement stack using array means it is fixed. I can store 10 elements means it is only 10, not more than that, but it can be less than that also. So for example, so this is the data structure, array data structure. For the implementation of stack, it says I am using 1D array, one dimensional array. So we use the one dimensional array to hold the elements of stack. And when I say it is 1D array, I have to make use of one pointer which keeps track of the push operation and pop operation, and that is what the topmost pointer. So top keeps track of the topmost element in the stack. And how much element I can store in this array data structure with stack implementation? So maximum stack size tells you, it is a constant value which tells you or which will provide you the maximum size of the stack. See, with the memory representation, if I want to tell about the memory representation means how we use this 1D array for stack implementation. I can view that in two representation. It can be a vertical representation, and this is the best representation that what we can analyze. So stack means it is like container, means it is vertical representation, best representation to represent the stack elements in memory. We can also write that in horizontal representation, just like how we see in arrays. But it's better to use this vertical representation. Just observe the maximum stack size that what I have given, if it is 5, means the stack is full. So it is vertical representation. Say the first element I push, it will be placed here 0, then I increase the top pointer. Well, we have discussed about the top pointer in the previous video. Please do check out the playlist. So we increase the top pointer, so top will be 0, the top plus 1, 1, then 1 plus 1, 2, 2 plus 1, 3, 3 plus 1, 4. When the top pointer reaches the maximum stack size minus 1, means 4, then the stack is full. The same thing with horizontal also. We represent in horizontal way. 10, 0, 1, 2, 3, 4. When it reaches 4, maximum stack size minus 1, then the stack is full. Then I start removing the elements. Push is done. Then I pop the elements, means the topmost element will be popped. The leaf ordering principle. Last inputted will be the first to come out. Last in, first out. 50 will go. Then I decrease the top pointer. Top equal to top minus 1. 4 minus 1, 3. 3 minus 1, 2. 2 minus 1, 1. 1 minus 1, 0. Then 10 is also removed. When everything gets popped out, then I say 0 minus 1. Then the top will be minus 1. So when top becomes minus 1, then I say the stack is empty. When top equals to maximum stack size minus 1, it is full. When the top pointer equals to minus 1, the stack is empty. So I can analyze that in the horizontal fashion also, or it can be in the vertical fashion also. So this is what with the static representation using arrays. Dynamic representation of the stack using linked list. But we don't know what is linked list actually. In the next coming videos, we will discuss about what is linked list. I can provide you minimum information like how this linked list is created and how we can represent dynamically the stack in memory. So what is this dynamic means? It is runtime representation, memory representation. During runtime, the memory will be allocated. So in arrays, we all know it is fixed. The amount of memory to be allocated is fixed. And the memory we are going to get in runtime itself. But during compile time itself, the memory will be fixed. And we cannot change that. Once it is fixed, it is fixed. Say if I say I want to store 10 elements, maximum is 10 only. We cannot store more than that, but I can store less than that. So the memory resource is wasted, but there is no problem for the user. But what about this dynamic? Dynamic says we are going to allocate the memory during runtime. We are going to predict the amount of memory to be allocated during runtime, and we use this linked list data structure to represent that memories. So we allocate the memory during runtime, and the allocated memory will be linked to each other, forming a linked list. The name itself tells you create a list of items and link that list of items to each other. So how do we create that? Means we create a node structure. We create a node structure. So we all know structure, it is a user defined data type. We create a structure in such a way that it will have two parts. How many parts? Two parts. One part will hold data. The other part will hold the link, that is address of the next node. So for example, data is 10 and the link is 200, means it will be pointing to a new memory block that what we allocate during runtime. And that memory is 200. So even this node will also be having some address, and the first node address will be held in start. It will be held in start. Say start will be having the first node address. So it will be pointing to this first. Then we go on creating like this. Say start pointing to the first node. So we create a self-referential structure. A structure we are going to design. How to create that? We will discuss that in linked list topic. Okay. So that node structure we are going to create. How much memory we require for that node structure? We will decide that during runtime. So runtime the memory will be allocated. So those nodes that what we create during runtime will be linked to each other, forming linked list. A list of items which are linked to each other. And the memory will be linked to each other. That is what linked list. So the first node address will be held in start. The start is a pointer which will be pointing to the first node. It will be pointing to the first node. So here we have two parts. One is data, the other one is link. So data is 10. Link is the address of next node. The next node address is 200. That will be held here. So again it will come to this node. Again I store data, link to the next node. So here it is 300, means it is pointing to this location. Here the data is 30 and link it is null, means it is not pointing to any other next node. So we go on inserting the nodes and we also delete the nodes. So I can insert the node in between, at the end or in the beginning. So at beginning I can insert, ending I can insert, in between I can insert. At the same time I can delete these nodes during runtime itself. I can delete the beginning node, ending node or in between node. How to do that? We will see that in linked list topic. So this is how we can represent stack statically and dynamically. Static is the fixed representation and dynamic is not the fixed representation. We go on allocating the memory during runtime, and the allocated memory in the form of node structure we are going to link to each other with the help of linked list. So this is what the memory representation of stack. So that's all for today's video. See you in the next video. Till then, take care. Bye-bye.